The first section deals with areas of rectangles, parallelograms, and triangles. Rectangles, parallelograms, and triangles. The first thing you need to know is, what do they mean by area? The area of a region is the number of square units needed to cover it completely. All right, so this is a two-dimensional thing we're talking about here. We are talking about a two-dimensional, like a flat surface, like a paper, right? Two-dimension, there's no depth to it. What would it take to cover the entire paper? That is the area, all right? Every region has an area given by a unique positive real number. Area cannot be negative. You cannot have a negative area, and it is unique. So it's not like if I gave all of you the same piece of paper and asked for area, I should get different answers. This will have one and only one area tied to it, okay? So that's what that postulate is saying. The first one we're going to look at is the area of a square. The area of a square. The area of a square is just the sides times each other, but because they are the same, it is represented as side squared. So squares have 4 congruent sides, which hopefully you know this from your test, all right? So to find the area, you just multiply side times side. And since they're the same, you just need to know one of those and square it. All right, so if you look at the example there, find the area of this square. All right, they didn't give us a set number of units. They gave us a picture, like a graph type picture. So if I look here, one side is 4 units across. Everybody can see that's 4 units across. And so if I wanted to find the area of this particular square, I would just say 4 squared, which is just 16 units. They didn't give me a units, so whatever the units is, that would also be squared. All right, if it has been feet, it would have been square feet, inches, square inches. It is my units squared. Area addition. So from this, we start moving into other types of problems. The first thing they talk about here is area addition. So if you have multiple figures put together, and you want to find the area of all of it, you can just add the areas of the individual figures. We're going to be doing some what's called composite figures, but this is going to help us develop the area formulas for the other things, all right? So for example, they put together 2 different squares, and if I wanted to do this, I would say, well, 40 squared, that would be the area of this guy, and 40 squared would be the area of this one as well, right? And if I wanted to find out the area of the whole thing, I could just add those up, all right? Which is where we get our formula for a rectangle. What happens with a rectangle is you end up just multiplying your entire base times your height. Whereas in a square, your base and height are the same thing. In a rectangle, they aren't. And so if you look at the area of a rectangle, that formula is just base times height. Base times height. And so you take the entire base, which is going to be something different than the height, and you just multiply the 2 together. All right, multiply the 2 together. I have here that the difference between a rectangle is a rectangle has a right angle. So you can just assume that the side length is the height. All right. A parallelogram has the same exact formula, base times height. So for rectangle and for parallelogram, we have the same exact formula, base times height. The difference is that if I have a rectangle, then I can assume that my height and my side length are the same because this is a right angle, okay? But in a parallelogram, they're not necessarily the same if it's not specifically a rectangle parallelogram. So in a parallelogram, you are going to have a perpendicular height given to you, all right? So you'll notice that you have 25 and 13 here, but your height is neither one of those. Your height is the perpendicular distance, all right? The perpendicular distance. Now they gave this one to you in a little bit different form, but I'm going to show it to you if I flip it around. My perpendicular distance is from one side to the opposite side, all right? So my perpendicular distance here is from this side down to the opposite side. That is my height. So for this, I am going to use the 10 as my height. Well, then the question is, which one of the other numbers is considered my base? All right. The base is the length of the one that you went in between. So remember with parallelogram, if this is 25, this is also 25. Because the perpendicular distance was from in between the two that are 25, that 25 is considered my base, all right? And I actually don't need this 13 at all. I do not need the 13 at all here. So to find this particular one, my base is going to be the 25. My height is going to be the 10. And so my area here is going to be 250. They gave it to me in inches. That's what that little double dash there means. 250 square inches. And I don't need the 13 at all at this point. I do not need the 13 at all. All right, so when they're talking about height, for a rectangle, it's just the side length because it is perpendicular. For a parallelogram, it must be the perpendicular distance from one side to the opposite side. And then your base is going to be the sides that you have the perpendicular going in between. Now they draw this out to show you what it looks like. For a triangle, you could take any parallelogram and cut it in half with a diagonal, and you would get two triangles, all right? And so you can see that you would get, if this was a parallelogram here, if they drew out the parallelogram, all right, and they gave me one diagonal, I created two triangles, and they're actually two congruent triangles, all right? And so if I take a parallelogram and get two congruent triangles, then I can start with the parallelogram formula, which is base times height. And so you'll notice base times height is part of the triangle formula, but we have to cut it in half because the triangle is only one of the two pieces of that parallelogram. So for a triangle, my formula is 1/2 the base times the height. Once again, it is perpendicular distance, okay? So for the triangle, I must use the perpendicular distance from a vertex to the opposite side as my height. The only time that you're going to have that is if you have a right triangle, and then you'll have a perpendicular distance from one to the other. But if you don't, it's going to go through the triangle. So let's look at this example that they've given us. Find the height if the area is 54. So they've given this to us a little bit differently. They want us to give them the height. They gave us the area. So we're going to fill in what we know and solve for what we don't know. My area formula is 1/2 base. They gave me the base. What is the base here? What is my base? 12 feet. All right, so we have 12 feet here. We do not know the height, so that's what we're solving for. We do know the area, that equals 54. So we just solve 1/2 times 12. That's 6, right? 54, what do I do to solve? Divide, right? So what is my height? 9, and specifically 9 feet. So make sure you put your units there, 9 feet. Easy enough? All right. This says find the area of the siding needed to cover the back of this building. What they've given us is they have actually given us a composite figure. All right, so we have this rectangle, which they have told us here is 27 feet by 12 feet. However, we do have these windows here, all right, and they have 2 windows down here. All right. And so there's 4 altogether, but these 2 windows down here, and they've given us that they are 4 by 3. So we know they're 4 feet by 3 feet. On top of this, we have a triangle. And so for the triangle, we have this basic here, if it'll let me draw it. And the triangle, they've given us a perpendicular height here of 8 feet. But we also have some more windows. And so we have to consider those as well, because we're not going to put siding on the windows. All right, so the first thing we need to do is figure out how much all of the area is, and then we'll take out what we don't need, which is the windows. All right, because we have 2 figures. We have a rectangle and we have a triangle. So the first thing we're going to do is say, well, the rectangle, that area is going to be 27 times 12, right? We're going to add to it the triangle, which is 1/2. The base of the triangle should be the same as the base of the house, right? It looks, I mean, they're right on top of each other. So my base is 27 here. The height of my triangle is 8. That would be all of it. From that, we have to take out 4 windows. The windows are rectangles. So I'm going to subtract 4 of my rectangles that are 3 by 4. And so with composite figures, you're literally looking at, what do I have? What do they want me to tell the area of? And I'm going to use all of my formulas, either adding pieces together or subtracting a piece out that I don't need. Sometimes you're going to have to draw your own lines. They're going to give you this crazy figure and you're going to say, oh, I have a rectangle here. I have a square here, right? And there might be a couple different ways to solve depending on what you drew, but you should end up with the same area. When you do this, 27 times your 12, you should get 324. Your rectangle is going to be 108. And then your 4 triangles are going to be 4 rectangles are going to be 48. So when you do all of that, the amount of siding you need is 384. This represents foot, right? 1 dash is foot, 2 dashes inches. So this is 384 square feet. So that's considered a composite figure. When you put together multiple types of figures, it's composite. Typically, they will shade what they want you to give the area of, and they will leave something not shaded when you should be subtracting it out. All right? Or sometimes the whole figure will be shaded, but you'll have to create different figures to calculate it. All right, so I want you to try one of these on page 301, number 8. The part that is shaded is what they want the area of. The unshaded, you're going to have to take out. So page 301, number 8.